Hey everyone! So in this video we're going to go over how to simplify polynomials, and the two main ways that we simplify polynomials is by collecting like terms or combining like terms and using something called a distributive property. When we're simplifying polynomials, we're typically just trying to get it into fewer terms or just kind of cutting down some of the mess. So here's one of the ways that we can do it. So one of the ways that we can actually kind of cut down on the mess is combining like terms or collecting like terms. And the way that we can collect like terms is by adding or subtracting terms with the same variable raised to the same exponent. Okay, so this is an example of, or this is the definition of combining like terms. And so let me give you a few examples. So example 1, right, we can combine the like terms 5x to the third power plus 7x to the third power, because they both have this x variable, right? This is something that they share in common. And the x variable is raised to the same power, so raised to the third power in both of these. So we know that we can combine those. So the way that we combine those is just by adding these coefficients or these numbers in front of these variables. So when I do that, I get 12, and then I'm going to keep that like term. Another example of combining like terms is something that you've actually done many times before. You can add or subtract regular numbers, and so that's an example of combining like terms. So something like 5 plus 7 is combining like terms. So we covered over combining like terms or collecting like terms, and another way that we can simplify polynomials is by just using the distributive property, and we usually only do that whenever we have a parentheses, right? So whenever we have a parentheses like this, and then there's some value in front of the parentheses, then what we want to do with that value is we want to multiply it to everything inside the parentheses, okay? And when we do that, we actually create an equivalent expression, right? So when we multiply x with 3, right, x times 3, then we get 3x, and x times 4y, then we get positive 4xy, and so this is going to be an equivalent expression to this long one with the parentheses. In addition, you want to make sure that whenever you're multiplying through, you multiply through your sign, and so if we have -1, then we're going to multiply -1 to a, and then -1 times -1. So this should actually be -1a plus, 1, because -1 times -1 is positive 1. So here's a check for understanding on how you can use the distributive property. Pause the video here and try these problems out on your own, and when you're ready to check your work, just press play. Alright, let's check our work. So whenever we are using the distributive property, we want to make sure that we are first circling our coefficient so we know exactly what we're multiplying through very clearly. So in this case, my coefficient is 3 because it's in front of the parentheses. And what I want to do with that 3 is I want to actually draw an arrow. Whoops. I want to draw arrows from the 3 to everything that I have to multiply. What I like to do, just so that I remember the sign, is I like to actually underline my terms that I'm going to be multiplying with 3. So the first thing I'm going to be multiplying is 3 times 4x. And the next term I'm going to be multiplying is 3 times 2. Okay, so let me just multiply those out. So 3 times 4x is 12x. And then 3 times 2 is 6. Okay, so this would be my equivalent expression. Okay, let's move on to part B. So -5 is the whole thing that's in front of my parentheses, and I want to draw arrows from -5 to everything I'm multiplying to it. So it's y and then -7, and I'm drawing those lines underneath those terms inside the parentheses, so I know to multiply to that entire term. So I have -5 times y plus -5 times -7. This is what I'm multiplying together. So when I multiply those out, I get -5y, and then -5 times -7, and negative times negative is a positive, so this is going to be plus 35. Let's look at part C. So for part C, I'm going to highlight -2 because that's the whole thing in front of my parentheses. I'm going to draw arrows to everything in my parentheses and underline each of those terms that I want to specifically work on. So I have -2 times n, which is -2n, okay, plus -2 times 9. So this is -2n, and then -2 times 9 is -18. So now that we know how to do the basic methods of simplifying polynomials, let's actually go ahead and try to add some polynomials together. So whenever we're adding polynomials together, the first thing that we want to do is just remove the parentheses. So let's look at this example over here. I'm going to remove the parentheses over here to complete step 1. So by doing that, I'm just going to write the entire expression just without the parentheses. Plus 3x squared plus 2x plus 1. Okay. And now I want to collect like terms, right? So when I'm looking for like terms, I'm looking for the same variable raised to the same exponent or just regular constants, right? So one set of like terms I see is I'm going to look at my first term, 2x squared, and I'm going to look and see within this expression, do I have another term with an x squared? And yes, I do. It's this term right here. And I'm going to highlight this term, and I'm going to include the sign that's in front of it, just so I know that I'm adding those two together. Okay, I'm going to go to my next term, positive x. I'm going to include that sign. And looking through my expression, I see that plus 2x is a like term, 2x, and I'm going to combine them together. And then I have 3 and 1 over here, so I can combine those as well. So let's actually combine those. So my first term that I'm combining is 2x squared plus 3x squared. So that's going to be 2x squared plus 3x squared. And then I have plus x plus 2x. And then I have plus 3 plus 1. So now I can actually combine those terms. So 2x squared plus 3x squared is 5x squared. X plus 2x, the x, there's actually a secret 1 hiding in front of it. So I have 1x plus 2x, which is 3x, and 3 plus 1, which is 4. Let's go over the second one, right? So the second one's a little bit more complicated, but first off, we're going to do the same steps, right? So we have x squared minus 2x plus 7 plus negative 2x squared plus 5x minus 1, all right? And then my like terms in this case, so I'm going to go term by term. Same thing, x squared and negative 2x squared, I'm going to bring those down. So I have x squared minus 2x squared. That's my first pair of like terms. My next pair of like terms I see here is negative 2x and positive 5x, so I'm going to bring those down. Negative 2x plus 5x. And then my last set of like terms are these constants right over here, so I have plus 7 and minus 1, so let me bring those down. Right. So now I just want to actually combine those like terms. So remember, whenever I have an x squared or an x, right, there's a secret 1 hiding in front of it. So I have 1x squared minus 2x squared, which is negative x squared. Negative 2x plus 5x, this is positive 3x. And then 7 minus 1 is positive 6. Right, so this is how we can add polynomials together, and we're really mainly using that simplifying or collecting like terms method. So another way that we can actually kind of visualize this, if adding horizontally is kind of difficult, we can add polynomials vertically as well. And so the first thing that we want to do is we just want to arrange the problems vertically. So we want to just kind of set this up. And then if we have any missing terms, then we want to use coefficients. So I'll explain how we can do that in our next example. Then we want to add our polynomials together, and then we want to simplify the sum by combining any like terms. So let's look through some examples. So let's look at example 1. So it's 3x squared plus x plus 1, and then it's plus negative 2x squared minus 2x plus 2. Okay. So when we're looking at this, right, we're seeing that the terms that are stacked vertically on top of each other are actually like terms, right? So I don't actually have to do much here, right? Because when I look down each column of what I'm adding together, it seems like I have a pair of like terms. So I have 3x squared plus negative 2x squared, and I can I know that I can combine those because they both have an x squared, so this is going to be 1x squared. And then my next term, I have x plus negative 2x, and that's going to be negative x. And my last term, I have plus 3. Okay. And let me actually change the color for that. Okay. Right. So that actually worked out pretty nicely. Let's look at this one, though. Right? Over here, when I look down this column, I'm not actually seeing any term over here. And then these two terms, 17x and 17, are not like terms. So this is where we would actually have to kind of muddle around with the arrangement of this. So I have negative 5x squared plus 17x. And then when I compare it to my bottom expression, I see that I have a constant as my last term over here, and I'm missing a constant over here. So I'm just going to leave this space blank for now. I'm going to move on to my bottom expression. So my first term in my bottom expression is this negative x squared. So I know that I'm going to combine it with this negative 5x squared, so I'm going to put it right underneath. So minus x squared. But my next term is a constant plus 17. I don't have an x term over here, so I'm going to just put this plus 17 over here. Okay. Now I'm going to just kind of replace everything that is an empty space with a 0. So this is plus 0, this is plus 0. I'm going to add. Right? So when I add these together, I get negative 5x squared plus negative 1x squared is going to be negative 6x squared. 17x plus 0 is going to be 17x. And then 0 plus 17 is going to be 17. And so this would be my fully simplified expression. Now when we're subtracting polynomials, this is when we actually start using the distributive property, right? And whenever we're subtracting polynomials, we want to imagine that in our distributive property, we're distributing the number negative 1 to our second polynomial group. Okay, so what I'm going to do for my first step is I'm going to use the distributive property to change the subtracted polynomial. And when I say subtracted polynomial, I mean the second group right over here, to an added polynomial, because I know how to add polynomials, right? So here's what I'm going to do. I'm going to take this negative 1 times 2x squared plus 6x minus 1, and I'm going to highlight this term that I'm going to be distributing, and I'm going to distribute it. Oops. I'm going to distribute it to every single term I see here. So I get negative 1 times 2x squared, which is negative 2x squared. I have negative 1 times positive 6x, so that's going to be negative 6x. And then I have negative 1 times negative 1, which is going to give me positive 1. Okay. And now I can just bring my original first expression down right in front of this. So I have 5x squared minus 3x plus 4. And now all I have to do is solve it like an addition problem. So I'm going to solve it by like an addition problem by combining like terms or collecting like terms. So I have 5x squared and minus 2x squared. And so that's going to be 3x squared. I have negative 3x and negative 6x that I can combine. And so that gives me negative 9x. And then I have positive 4 plus 1, which is positive 5. And so that's going to be my final solution for this. And I just realized. So again, if you're having trouble doing this by subtracting polynomials horizontally, you can also subtract them vertically if that's going to help you to just stack them up. So the first thing that you want to do is just make sure that both polynomials are in descending order. And when I say descending order, I just mean your exponents go from highest to lowest. So let's look at this, right? So when I'm looking at my first expression, negative 3x plus 4, I know that x has a higher exponent than this constant 4, so this looks fine. And over here, I see that my exponents are going from 2 to 1 to 0, so that looks like it's in descending order, so it looks like we're good with the first step. My second step is to just write the polynomials vertically with the like terms aligned, just like how we did for our addition problem. So I'm going to write the first expression on the top, so I have negative 3x plus 4, And then I'm going to write my bottom expression, so minus, and then negative 2x squared is going to go out in front of the minus 3x. And then I have plus 6x, and then minus 1. And so all of my like terms are combined, or not combined, but they're stacked on top of each other. Now I'm going to replace any missing terms with terms that have a 0 coefficient. So I'm going to put a 0 coefficient right over here. So I'm going to put 0x squared minus 3x plus 4 minus negative 2x squared plus 6x minus 1. Right, just like how we did in our previous problem. I'm going to multiply the bottom polynomials by -1, so I'm going to distribute this -1 to every single term in the bottom expression. So I have 0x squared minus 3x plus 4, because I didn't do anything to that. I have -1 times negative 2x squared, which is positive 2x squared. I have -1 times 6x, which is negative 6x. I have -1 times -1, which is positive 1. I just realized I made a mistake right over here, so let me just fix that right. This was supposed to be a negative sign, so let me fix that. There wasn't supposed to be a negative sign there, no negative sign there, and so this should be a negative sign. Sorry. Okay. Now all I have to do is just add the polynomials, right? So when I add the polynomials, 0x squared plus negative 2x squared is going to give me negative 2x squared. Negative 3x plus negative 6x gives me negative 9x, and then 4 plus 1 gives me 5. So why don't you take a minute to just try this check for understanding over here, where you're kind of finding each difference. And then when you're ready to go over your work, I'll pause the video and we'll go over it together. All right, let's go over this problem together. So we have 2x squared plus 2x plus 3 minus x squared plus 2x plus 1. So I say that it's a subtraction problem, so that means that I have to distribute that negative sign to the entire second expression, or the subtracted expression right over here. So I'm going to do that first. So I have -1. Let me change the font color. I have -1 times x squared plus 2x plus 1. And I'm going to be distributing this -1. So when I do that, I have -1x squared, -2x, because -1 times 2x, and then -1 times positive 1 is -1. I'm going to bring my original first expression down, so 2x squared plus 2x plus 3. Okay, now all I'm going to do is just combine like terms. So I have 2x squared and minus 1x squared. So that's going to give us 1x squared. I have 2x minus 2x. And so 2x minus 2x is 0, so I don't actually have to write a term there. Those kind of cancel each other out. And I have 3 minus 1, which is 2. So this is my final expression. Right? It's much preferable to write this short expression than to write this whole long expression, right? So this is why we simplify polynomials. Let's look at the second one. I have -3x squared plus 4x minus 1 minus -x squared minus 4x. So I see that those like terms are not horizontally stacked on top of each other. So I'm going to just do that really quickly. So I'm going to just copy down the first expression, right? -3x squared plus 4x minus 1. And then I have minus, and I'm going to put this -x squared directly underneath this 3x squared. I'm going to put this minus 4x directly underneath that 4x. And then I don't have a constant term, so I'm going to just fill that in with a 0. All right. And I know that whenever I'm distributing this negative sign, I need to multiply -1 to every single term in the bottom expression. So let me just get rid of this really quick. Okay. We're going to turn this into an addition problem by multiplying these out. So -1 times x squared, -1 times -x squared is going to be positive x squared. So let me write that. -1 times -4x is going to be positive 4x. So let me change that to a plus sign. And then -1 times 0 is still going to be 0. I can change that to -0, but it's not really going to make a difference. But just for educational purposes, I will change that to a 0. minus 0. Okay, and now I just have to add those stacked terms. So I have 3x squared plus 1x squared. That's going to give me 4x squared. 4x plus 4x gives me 8x. And then negative 1 minus 0 is just negative 1. So this is my fully simplified expression. So hopefully that was helpful to you. You have some practice problems that are on Google Classroom, so I recommend that you look through those, and good luck.